Okay, so this is the first video on quantitative analysis. This is the two key topics here. The first one we're going to look at is the high-low method, which we've talked about before. And I think we saw that when we were looking at pricing and even costing. But we're going to talk about the high-low method, and it's just, if you like, a method for finding out, playing with equations somewhat. But we're going to use the graph to sort of do this. And then the second thing we're going to look at is the learning curve. So this first video will be on the high-low method. Right. Okay. So let's expand this very quickly and see what the story is here. So, I mean, what is the high-low method? The high-low method really arises from having, if you like, this sort of idea that total costs are equal to variable costs plus fixed costs. So what happens is you're basically just trying to break up this equation and to find out what the variable costs are, right? And this is, I mean, you know this already. We know the variable costs remain the same with the number of units. And then we get total costs. So in a way, you could argue that we can have an equation which says, hey, put this again, y, where y is total costs, is equal to mx plus c. And so where m is the variable cost, x is the number of units, and c is the fixed costs. And if you remember from your break-even charts or whatever, this is your curve, isn't it? It starts here. And then you have your variable cost, if you like, which, with the number of units as you go up. And this whole thing becomes your total cost, of course, because that's a combination. Like I said, your total cost is a combination of your variable cost and your fixed cost, which is taking it up this way. So your fixed cost is over here at this level, and your variable cost is what's taking it up. The difference between your total cost and your fixed cost, isn't it? I mean, that's what total cost is. So all we're literally doing is saying, the thing is, the issue here is we have this. I mean, again, it's quite straight. You have a situation that looks like this, and we have figures. We're given information across here, and the argument is the high-low method says you have the highest, you have the lowest, and based on that, we can find any information we need, even this, even though we never had it. So if we have this, if we have 2 points along this curve, we can find the fixed cost, which is this, which is equal to c, technically, in terms of equation notation. Or we can find the variable cost, which is the slope of this curve, because it's by how much variable cost rises, and that's a fixed amount, isn't it? That's a fixed amount with every unit. Remember, the variable cost is equal to marginal cost, right? And marginal cost is really the cost of producing the next unit, which is direct cost, which are variable costs. Okay, right. Again, like I'm just highlighting what I said, we can then sort of find out whatever it is we need. So, again, what we're saying is that we need to select the highest, the fundamental steps, select the highest and the lowest activity levels and their associated costs. It says do not take the highest and the lowest costs, take the highest and the lowest activity levels. Really, I don't really think this matters. The key point is it's a straight line, and as far as math is concerned, you're always going to arrive at the same answer. Calculate the variable cost per unit, and that's really the slope of the curve, which we'll do in a second. And then we can find the fixed cost by just plugging our answers into any of the equations, absolutely any, and then we can carry on from there. And then we can make forecasts, and we can sort of, based on that, we can, if we know the variable cost per unit, we can multiply that by any number of units and just add it to fixed costs. So we're fine, and we get the total cost. So that's pretty much where we're going. So let's look at an example in your textbook. I'll discard those. Your textbook has a nice little example here, and it says that you've been given cost data. It says that you've been given cost data for 6 months, and these are the total costs over here. at each of these units, level of units. And then it wants you to go ahead and forecast when the total costs are 500, when 500 units are produced. So we're in chapter 9, by the way, on quantitative analysis. Let me just get the page for you. We are on page 305. So, first of all, what I need to find is the variable cost. Again, so you can really see what's going on here. This is what I have. I want to find out what this is going on over here. But I know my units. My units are along here. And my total costs are along here. So, I'll pick, in terms of activity, I'll pick my lowest and highest activity being 420 and 300. So when my units are 300, my total costs are 160. And when my costs are 420, oops, better change that, doesn't work very well. My costs are 400. So I have this scenario here. I basically have, I can find the difference here. This A over B will give me my variable cost. Yes, and that's what we're really trying to do. The difference between this and this, or the difference between the 400 and the 160 divided by the difference between my units. And we did this, I believe, when we're looking at pricing, when we're doing a bit of costing there. So 400 minus 160 divided by 420 minus 300. And I believe this is 240 divided by 120. And that means that my variable cost, according to my equation, this whole y is equal to nx plus c, I'm looking for n fundamentally. N is equal to 2. My variable cost is £2. Well, I'm there now because if I pick a number of units, you literally could just go ahead and pick anything. I'll pick this one. Okay, we'll pick July. So I know that y, my total cost, which is given to me. So in July, total cost is 2240. 224 is variable cost 2 times 340 units plus my fixed cost. So I'll find, so 2240 is equal to 680 plus FC. That means that FC is equal to 2240 minus 680. 0, 14 minus 8 is 6. 21 minus 6 is 15. So that means my fixed costs are 1560. And you can test this. I mean, check. I believe. I'm hoping. I'm sure I'm right. And so that's how we find that. So now we have the equation. We have the y is equal to 2x plus 1560, which means that whatever units I pop in here, if I pop in 500 here, which is what the question is asking, which becomes y is equal to 2 times 500 plus 1560. So that's 1,000. That's 1,000. Plus this 1560, I will get 2560. So my total costs at 500 units, which is what they're asking for, is 2,560. So you can see I could keep going, can't I? Because that's what it's saying 500 units, what's the total cost? And sorry, my pen isn't good. And that's sort of bringing you up this way. So what's the skill to this? Pretty much pick your highest and lowest activities, chuck it on a graph, find your gradient A divided by B. You've therefore found N. you know what the total costs are, you can find your fixed costs, and you can plot on from there. So again, it's about doing a few questions just to get comfortable with the process. Let's just look at some more theory. At some of the, I've said y is equal to a plus bx, but it could be y is equal to, it doesn't really matter, it's just a linear model. The process is really the same. So what are the advantages? It's easy to use, easy to understand. Disadvantages, it's possible that it might not be as smooth as we think in terms of this idea of saying we're only using two values. The highest and the lowest results may be sort of different within, but it also assumes that costs aren't increasing. So we're making the real assumption here is that costs remain fixed throughout, or if you like, variable costs do not change, which we agree, but fixed costs might do, and variable costs in terms of wages might actually go up because people, to make them work harder, you'll have to pay them more. And it just pretends that there are no other external factors involved. So that's the first video, and that video is on the Highlow method. In the next video, we will look at learning curves. Okay, great stuff. See you then.